Okay. I want to point out that when red pen, black pen did the problem, there was a problem with his answer, by the way. I'm not too concerned about that. And by the way, I wouldn't be overwhelmed with this either, because a lot of times what your calculus teachers give you is they give you these like recipes that do work under very restricted conditions. And this is one of the substitutions that works under a very restrictive condition. And those conditions are stated over here, by the way. All right, that substitution works nicely. But I want to point out it's not entirely true, by the way. It's what's known as conditionally true. For example, when I make that substitution over here, that this equals a tangent of theta under the conditions that we state. Now, certainly if you're doing a problem, those conditions probably should be stated. Now, if you're taking a calculus course, remember you're taking, a lot of times don't even expect you to put the condition down. They say just accept it, that these conditions are going to be held, all right? But that's not true, all right? So when I went through it, I got through it, we got an answer, and I want to point out when I did Sage, I realized that an error occurred, all right? So what I want to do is just, kind of briefly talk about what Sage reported back to me, and I'll write this one down for you. Sage reported back to me minus the arc sine. But I don't think Sage answers any much more informative at this point. But I see 1 over 3 absolute value of x. And I'll put the constant integration over here. All right? By the way, I want to, again, emphasize over here that this is conditionally true. All right? Now, conditionally true, it's really one of two conditions over here. The tangent squared of theta, when taking the square root of that, I'm over here now. It could be tangent of theta, under certain conditions, by the way, but it could also be minus the tangent of theta. And that's where these problems are popping up, by the way, that we're not even looking at that. All right, let me see if I wrote some other things down over here. So it's really the absolute value of that, which makes it increasingly difficult to think through the integrations. All right, but the bottom line, you can go back and do this again and make two cases over here. One where the tangents, there's going to be plus the tangent of theta, the other one opposite of tangent of theta. And again, you get different things over here, but the bottom line is getting through these things over here does require some thinking. And this is why it's so nice to have software. All right? So let's rethink a little bit anyway and talk about that. All right? So I want to go through what Wolfram did. And certainly Sage is nice. I'm not a good fan of its information over here. But I also used the Wolfram. And Wolfram, in my opinion, returned the best answer. All right? My original work, though, was only true for a certain set of values. And the set of values it was true for is when the x was greater than, make sure I'm writing that down, or equal to 1/3. All right? Now, by the way, the domain of these things over, you can figure that out, and I'm just using one branch of it, which would be x is greater or equal to 1/3. But there's another branch where it would be below the minus 1/3. And this is what's being done over here, that this we're going to work on the entire domain of the problem, by the way. That I'm not worried about restrictions over here. Again, where did the problem creep into the problem over here? In this stage, sorry about that. At this stage over here. It crept in, all right? Thank you.